All right, guys, we've got lesson 7 here, systems of equations. And to begin with, of course, we'll start with our bell work. And so if you haven't had a chance to do it, please just pause the video and give it a try. All right, assuming you gave that a try now. We've got a line, we've got a slope with 4, that's our m, and it passes through this point, which is, of course, xy, which means we're going to need to solve for b. So let's start by writing out what we know, which is that y equals 4x plus b. And then we can use this point here, like we did last lesson, to solve for b by plugging in 3 for y and 2 for x, giving us a way to solve for b. So we get 3 is equal to 8 plus b, subtract that 8, and we get negative 5 equals b. Therefore, our equation is y equals 4x minus 5. Awesome. All right, let's jump into the lesson proper here. So now we've got a system of equations. So given two lines, find the point of intersection of these two lines. So remember, when we've got lines like this, we've got three options. Either they're parallel, meaning that they never cross, they have exactly one solution, or our last example, this is going to look kind of weird, but like they are literally the same line and they have an infinite number of solutions. Those are our possibilities if you remember from previous classes. So this one is clearly this example. It's telling us there's one intersection. So let's go ahead and find that. So there's a couple ways we can do it. We can do it with elimination or we can do it with substitution. I'm going to do this one with elimination first and we'll do some with substitution later. Okay, it doesn't matter which one you do, you can always do both of them. Sometimes one of them will be a little bit easier. All right, so in this case, why am I choosing to do it this way? Well, the reason is actually this. If we stack them on top of each other, you can kind of see here, it's pretty easy that if we subtract this second equation, we can get elimination by getting rid of that y. So we'll get 0, 2 minus 7x is negative 5x, and 1 minus negative 2 is 1 plus 2, which is 3. So this would be 1 minus, yeah. All right. So then what we want to, then what we want to do is move this over. So minus 3, we get negative 3 is equal to negative 5x, and then we can divide by negative 5. And so we will get 3/5 equals x. That gets us partway there. Now we just need to find y. We can use either equation. It doesn't matter which one. I'm going to use that first one, but like I said, it literally does not matter. And what we're going to do is plug in this value of x into that equation. And so we will get y equals 6/5 plus 1, which of course we can rewrite that 1 as being 5 over 5. Why am I doing that? So that I have that common denominator. And so y is equal to 11/5. So that means that my point of intersection is going to be 3/5, 11/5, like so. And that'll be my solution. Okay? Hopefully that rings some bells. You're remembering some things from before. Yeah. All right, let's do another example here, and let's look for another point of intersection. Now this time, this one definitely looks like it's going to be easier with substitution, and just so that I've covered both ways, I'm going to do substitution for you on this one. Okay, why do I say that? Because this one is solved for y, and this one is not, meaning that the easiest thing for me to do is to plug this value in and substitute it in for that y. Meaning my equation will become 2x plus 3, and instead of y, I'm going to write that second equation, or first equation, I should say, and write it out like that. Then, of course, I need to simplify. So I'm going to plug that 3 in and get 2x plus 12x minus 21 equals 0. Then we bring together our like terms, and so we will get 14x minus 42 equals 0. Then, of course, I need to pass that over to the other side and get that 14x is equal to 42, and then I would divide both sides by 14, which gives me that x is equal to 3. And again, we're partway there now. So then my next step is to plug that into either of those two equations. It doesn't really matter which one, however, that first one's definitely going to be easier because it's a more simple equation. So I'll plug that 3 in for x, and then solve for what y should be. So 12 minus 7, y is going to be 5. So that means that my point A, because they're labeling it this time, A is going to be the point 3 comma 5. All right, and that's where these two lines will intersect. All right, so now we've got a practice one. So as always, give it a pause, guys. Give that a try, and then, of course, check back in. All right, so hopefully you're able to do that, and hopefully you identified that this one is much easier with substitution. And the reason is simply because, like I said, we've got a complicated equation, and we got a simple one that's solved. So we want to take this and plug it in for our y. So we're going to get 4x minus 2, 5x minus 7, where we plug in that first equation, minus 25 equals 0. So that'll be 4x. I'm going to distribute in this negative 2 and get minus 10x plus 14 minus 25 equals 0. Then we put all things together, so I get negative 6x minus 15 equals 0. Pass the 15 over by adding it to both sides, and I get negative 6x equals 15. And then, of course, divide by my negative 6. And x is going to be... that is not right. That is not right. That is not a 15. Hang on there. 14 minus 25 is definitely negative 11. Sorry about that. So then I'm going to add 11 to both sides instead. And I'll get negative 6x equals 11 divided by, and I can't actually simplify that. That's just going to be negative 11 sixths. But now I can take that, plug it in to find my y. So let's use that first equation. It's a little bit easier. So plug in that negative 11 over 6 for x. I'm going to get negative 55 over 6 minus 7. Then I need that common denominator. So negative 55 over 6 minus 42 over 6. And that's just me taking this one that's over 1 and multiplying by 6 to get that common denominator. That's going to then tell me that y is equal to negative 97 over 6. And I cannot reduce that. So my point A, because again we're looking for point A, is going to be negative 11 sixths and negative 97 sixths. So a little bit more complicated numbers, but not anything different than what we did last time. So hopefully that's what you were able to find. All right, now example 4 here. Okay, now let's see. We got a line passing through this point has that slope. Line intersects with another line as this equation. Point P, find P. Okay, so the first thing is we don't actually have an equation for that first line. So we're going to need to find it. So we know that it's y equals the slope x plus b. And then we can use this point here to sub in and find b. So we're going to get 6 is equal to negative 2 times 0 plus b, which means that 6 is equal to b. All right, so that means that equation is y equals negative 2x plus b. Now we've got two equations, and we can see again that probably the easiest thing for us to do is do a substitution. So 5x, the reason is this one's solved for y, so trying to do it with elimination is going to be a lot harder. So I guess I should write that in there. We're going to use substitution. Okay. So where was I? 5x minus 8, and then instead of y, I'm going to plug in this equation. So negative 2x plus 6 minus 15 equals 0. So then we simplify this by taking that negative 8 and plugging it in. So we will get plus 16x minus 48. Yes, minus 48 minus 15 equals 0. And put those together, I'm going to get 21x minus 58, 63 equals 0. Put that 63 over to the other side so that we can start to solve this. So 21x equals 63. Divide both sides by 21, and I will get that x is equal to 3. Then I need to solve for y, and again, it's always easier to use the more simplified equation if you have one. So negative 2, change that x to a 3, plus 6, and I will get that I've got negative 6 plus 6, or the fact that y equals 0. So point P is going to be 3, 0. That will be my point of intersection here. All right, guys, and that brings us to the end. So then you guys can go ahead and put this into practice with these formatives, and yeah, good luck with it.